Hello. Um, my name is Angjelko. I need to repeat myself. Hope everyone can hear me. I'm a software engineer at Monta, a software company in the EV industry. I've been working with Flutter since the early alpha stage, and this is my second time doing being at the conference, uh, doing a talk. I was the first time I did it last year here as well. And when I was trying to come up with what am I gonna talk about, I wanted to do something a bit more advanced, but also something I really enjoy working with. And I looked up on the Flutter repo the most recent issues with Slivers, and there was a request for a sliver expansion tile. So that's what I did last year. I worked on creating how to create a custom sliver expansion tile. And then this year, when I got the invitation to submit for another talk, again, the criteria was the same. I wanted to do something a bit more advanced, something fun. So I decided to talk again about, sorry, the slides are not up. Yes. Yeah. So this year, again, I'm going to talk about slivers. And I felt a bit lazy. So I'm going to talk about how to create a custom lazy sliver. So this is kind of an extension from last year. Consider it a part two. So I'm not going to cover lots of the basic stuff, only the important parts on how we can turn our existing sliver widget into a lazy one. So I really recommend to go and watch the last year talk as well. But before moving on with the actual implementation, I want to mention few parts that I consider it to be important when it comes to slivers. First is the sliver constraints. Then we have parent data, and then the sliver geometry. Now, the sliver constraints gives us lots of informations that we can use to understand the position, the direction, the axis direction, the scroll offset of the viewport, of the sliver in the viewport, and lots of other properties. The ones we are going to focus on today is the scroll offset and the remaining paint extent. Okay. Now, the scroll offset gives us the offset position, as the name implies. And the funny thing about this, most of the time it will be equal to 0. Doesn't matter if it's in the middle, if your sliver is in the middle of the screen or it's on the top, it will be 0. The only time the value might change is when it goes past the top edge, and then the value goes into negative. If we go on the bottom side, the value will stay 0. Doesn't matter if it's at the bottom of the edge or past that, it will stay 0. Now you may ask yourself, how am I supposed to know how much should I paint with from the sliver? That's where the remaining paint extent comes up. It gives us the amount of paint that we are left that we can paint our widget. And as we go towards the bottom edge, the value decreases and reaches 0. Now, the next one in the list is the parent data. And I consider this a really powerful part of the Sliver API and in general It's also available on the, in general for any render object, including render box. And it's a way for us to store information, valuable information that we might find useful as we move on the during the layout phase and the paint phase of the widget. So for each child, wherever, depending how you're gonna write your logic, your algorithm, you will store different kind of data. For this situation, because we're gonna create a lazy sliver, we're gonna rely on the sliver multi-box adapter parent data, which provides us with the layout offset to properly lay out the children in the sliver. Here's a snippet code of how would that look like. As you can see, I've added few information like the child extent, the total extent, the next possible layout for the next child, um, and as well as a custom method that will help me to predict, calculate the next possible information depending on which child I needed next. Lastly, we have the sliver geometry. Now, this is the last step you do when you in the last layout phase. So after we gather all the information that we need to set the geometry with a bunch of informations that will help the viewport and the sliver to properly render on the screen. The most important ones for us is the scroll extent, the layout extent, the paint extent, and the max paint extent. And here is a visual example of how would that look on the screen. So in most of the cases, the layout extent and the paint extent are basically the same. The layout extent cannot be more than the paint extent. And the scroll extent is the the scroll amount the user is able to scroll with this sliver. Now, the one thing I love about Flutter is the rich catalog of widgets that it provides us. Like, there are a vast majority of components that we can use out of the box. So you may ask, what's the point of creating a custom widget, a custom sliver? Well, there can be different reasons. Like, you have a really niche application that uses really niche UI driven functionality that just the current components cannot do, or it's using the current components, it doesn't provide the exact thing you want or the performance you need. Or maybe your favorite widget has a bug and you want to go and make a contribution and open a pull request. So apart from having this rich widget catalog, the Flutter team has, the Flutter framework has this, provides us with render sliver APIs that will make our life easier when creating custom slivers. Specifically, in order to create a lazy sliver, we'll rely on the sliver multi-box adapter widget, which provide us with a few properties and methods in order to make our widget, our sliver, a lazy one. The first one is the child manager, which basically, as the name implies, manages the children that were passed down through the sliver delegate. Next is the add initial method, which basically tries to add the first child in the list, create a render objects of it. Then we have the insert and layout a leading child, which is quite a clever method that tries to insert and lay out a child before the first child. And if If it doesn't have enough anymore, it tries to get one from the child manager. If it's out, then it will just return a null. And of course, we have the counterpart, which is the insert layout child, which accepts an after parameter for which we pass a child and tell it, okay, insert and layout, try to insert and layout a child after this child. And again, if it doesn't have any children anymore to insert and layout, it will return a null. Now, when it comes to cleaning up, we also have three methods. We have the calculate leading garbage, which basically accepts an index and tells it, okay, calculate how many children we need to remove before the index provided. And of course, we have the opposite one, which is the calculate trailing garbage, which calculates the amount of children after the index provided. And then when we gather that amount of children, that number, we can pass it to the collect garbage that accepts a leading amount and a trailing amount, and it will do the cleanup under the hood. The last two utility methods, I would say, is the paint extent of, which basically returns the paint extent of each child. So depending on the scroll axis, it can be a width or a height. And also the index of, which just returns the index of the inserted child in the child manager list. And finally, let's not forget that thanks to the extension of this class, we get to use sliver delegate. Instead of passing a fixed list of children, we are able to use sliver delegate to manage this. Now, there are few, I would say there are three states when it comes to children in lazy slivers. The non-inserted one, where the children hasn't been, the render box version of the child hasn't been created yet. So we only have the boil print codes that were passed down by the sliver delegate. I imagine this like a basket of children widgets that haven't been inserted yet. Then we have, of course, the inserted state, which creates a render box, adds the children to the render tree, but hasn't laid them out yet. They don't have size, they don't have width, they don't have height. And the last one is inserted and laid out, which, of course, apart from inserting, also lays them out, calls the layout method of each child, and that allows us to have each child to have its own size, a height and a width. Now, going to the main part, when I was working on the logic, on the algorithm for creating the lazy sliver, I managed to split the perform layout in 4 steps. I call it the 4 layout steps. The first one is the initialize, where we tell the framework, okay, we are starting. Do we have our first child already laid out? And if we don't, can we add our first child? And the last optional step is if we were not able to add the first child, that can happen if the sliver delegate doesn't have any children passed on, then we will wrap up, tell the geometry, set the geometry to 0, and tell that we are finishing the layout. And all of this has its own methods or properties, like the did start layout of the child manager. Then we have the first child property, which checks if the first child is available or not. Then if the first child is not available, we call as I mentioned earlier, the add initial child, which returns a boolean. And lastly, if it's not able to add it, we call the did finish layout method of the child manager and set the geometry to 0. Here is a snippet of a code. How will that look like? So we start the layout, we check the first child and try to add it. Now the second step, I call it shuffle and clean. In this step, we lay out, the child and also update the parent data for it. We set all the necessary information that we need. And then we also, as we updated all the layout offset, laid out the children, updated all the parent data, we can see, okay, which of these children we don't need anymore, which of these needs to be garbage collected. And all of these have its own related properties or methods. So we use the parent data, of course, and we use the collect garbage. Now, here's a snippet of a code of how will that look like. And as you can see, we call the layout method of the child. We calculate the parent data with the method we used before. And as we've done that, now we are able to see, okay, which are the leading and trailing garbage child that we need to use in order to clean the children that we don't need. So we use the methods I already mentioned, and lastly we call the collect garbage. The third step is the insert and layout. And here we ask, should I insert and layout before or after? We try to do both because, of course, we have a top edge and bottom edge. And here we use the methods that we mentioned earlier. We try to use insert and layout leading child, and we try to use insert and layout child. And here we don't pass any children to them except for the insert and layout child, which accepts an after parameter, as I mentioned. It automatically knows how many, if there are any other children that needs to add that haven't been inserted and laid out yet. Again, here's a code snippet of how that will look. So first is the insert and layout leading child. We go through each, we update the parent data, and we don't need to call the layout method of the child because the insert and layout leading child method already does that for us. And here's the trailing version of it. And yeah. Now the last step, the finish step, is we gathered all the information, we updated all the layout, we set everything that was needed to be done. We gathered the scroll offset, the paint extent, the max paint extent, all of that. And now we need to set the geometry. Now we need to tell the viewport, okay, this is how much the sliver will be large. This is the children will it have. And yeah, great work. To wrap up, here we use again the sliver geometry as I mentioned. And we call the did finish layout method of the child manager to let it know, okay, we are done. Here is a code on how that will look like. So we are setting the geometry, we are setting the scroll extent, the paint extent, the max paint extent, and even the has visual overflow. And we call the did finish layout. Lastly, here's how a simplified version of the paint method will look like. So as you can see, we go through all of the children and we just access the layout offset of their parent data in order to paint the children at the right offset that is their layout offset. And now I can show you a demo of how that look like. Just a second. So just need to build up. Okay, so as you can see, as soon as we scroll, I've set some pre statements in order to see how it works under the hood. So this is the sliver expansion tile widget that we built last year, but now we turned it into a lazy one. And as you can see, it says the total children that are available are 7, but only 1 is laid out. And if I expand this, it will say now it has 7 children laid out. If I close it, it will go back to 1. Let's see how it looks like in slow motion. As you can see, as the widget more expands, the laid out widget increases. And same goes when we close it, the amount decreases. Even if halfway we stop the sliver expansion tile from expanding, it won't go further from laying out more children. Now, another thing here is that as soon as I start scrolling out of the past the edge, the amount of laid out children decreases and stays 1. Same is if I start scrolling down, the amount decreases. The reason why it's always 1 is because we need an anchor child that we can use to expand the list from. And yeah, that's all. Thank you all for listening. You can scan the code, and the code is already available in the repo. It's under different branch as it still needs some final touches. The branch is called Lazy Sliver, but I also have the actual last year implementation published a few weeks ago under a package. Thank you so much.